Hello, PreCalc. How's it going on your break? I promised to get this up around Monday, and so Monday it is. So 11/21, and that's 2016. So sometime this week, before Monday's class, watch this video and take notes. All right, so let's go ahead and talk about the law of sines. I think we are going to finish up on that today. So let's see what's left. We have noticed that if an angle, say you had an example, I think this is one that we have done, so I'm not going to do it again, but say angle C is given and B is given, and little b, meaning the side opposite. These larger letters represent angles. The smaller letters are the sides opposite. So we'll draw it A, B, C. And we'll see this one doesn't make sense because C is very large angle. So let me stretch out angle C to make a large angle. See if this makes more sense. So C is 102.3 and B is a 28.7 and little b is 27.4. And we've solved ones like this before. And what I want to mention about them is if we go in this, start here from what we know and we go clockwise around this triangle, we are giving an angle, then an angle, and then a side. Notice that is not a bad word. So angle, angle, side is what we are given in this one. And that one worked out fine when we did that. And then we did a different one. I think it was the one with the pole that was leaning. We had some practical ones. If you remember that one. I think these were the numbers that were given for that one. So on this one, if I draw A, B, C, and we get at little a, and big B. All right, so on that one, if we mention what we know, starting here and going around, we would get angle, angle, side. That matches this one. And these present no unusual cases. We have seen another one though. This is the one with the tree. The Dr. Seuss tree, remember that one? It went like this. We had a small angle, larger angle, and we knew this. So if we go around like that, what do we know? We knew angle, side, angle. All right, so none of these have caused us any pain. We just did them and got the answer and went on to the next one. However, there is a tricky case, and the tricky case is this. Sometimes we are given in a situation where we know two sides and one angle opposite one of those sides. So I'll make it A. So when we draw that, so I'm going to draw what we know. We know angle 85, so that's pretty big. Angle 85 is A. And B, I don't know where that is, but somewhere down this line there's going to be, we're going to stop and create an angle B. Side B, we do know, it's pretty long, 25. And little a is 15. And we don't know this angle right here. So, if you recall, this is the case that I did show you, but I didn't tell you that it was what its name is. And the name that we give this is, I'm going to start here and go around. We call it side angle. Again, that's not a bad word, but if we were going to look at it backwards, we wouldn't want to say what it says. So that's a way that you can remember that this is the tricky case. And we actually call it the ambiguous case. The ambiguous case. All right, so I'm teaching you SSA when you're given these kind of numbers and angles, that this is the ambiguous case. Ambiguous means, well, it could be one answer or it could be another answer. So it's not clear, it's ambiguous. All right, we actually had one like this, so I'm not going to go, I'm just going to do it really quickly and not ask you to do it again. But when you set up A over sine A, B over sine B, in order to figure this out, you get 15 over sine of 85 equals 25 over sine B. And when you get sine B by itself, you end up with a 25 times sine of 85 divided by 15, and that is when you do inverse sine of this number actually comes out to be 1.66. Ouch, you can see the inverse sine of 1.66 is error. In other words, there is no angle that has this as its sine, because we know the sine function goes up to 1 and down to -1 and back and forth, never higher than 1, never reaching 1.66. So we saw one like this, and I said if something like this happened, we'd say there's no triangle. Now this picture up here gives you a good idea why there is no such triangle. This 15 isn't long enough in combination with this angle and this side to create a complete triangle. No matter where I pick the angle here, I can spin this 15, try it all different places, go all around trying to make a triangle out of it. It'll never reach this side no matter where I spin it. So probably the closest I can get to that side is about there, and it still leaves a gap and there's no triangle. And without a picture, your algebra trig will tell you the same thing when you reach an error message. So no triangle. All right, so that's what we've done so far, but I didn't mention that that case was the SSA. So we're going to take SSA one step further today. All right. Well, in SSA, this next one I want to look at is going to be like this. SSA, again, well, you won't know it's SSA until you look at it, so I'll pretend we don't know that it's SSA. Little a is 12, little b is 31, and capital A is 20.5 degrees. So, a quick sketch of that. So if I put A at 20 degrees, B is pretty long, and A, this is B somewhere, A, C, this is little b. We're going to try to find little c, and little a we know is 12. The question is 12, c equals 12, I'm sorry, little a equals 12. The question is that 12 long enough to reach down here to this side here? So we're not sure if it makes the complete triangle or not. So does this side 12, I don't know how long that is. If this is 31, 12 is what, a little over half of it? Does it quite make it or not? So that's the kind of question we have. And do you see that it is a side-side angle case where we know two sides and an angle? All right. Well, with this one, I actually drew it out fancy schmancy for you, in that I actually drew it to scale just to show you, and to Let's go back. All right, there we go. Go back here. And I actually took my protractor and I drew a 20.5 degree angle. Set it up here, and right there's the angle 20.5, and I used a scale. I did 1/2 centimeter for each of these numbers. So I made this 31 with that scale. And now I cut out a little piece of paper that I can move around, and that represents the 12, and I drew it to scale. So if I put that on the tip of this side, which is 31 at 20.5 degrees, you'll see that it is long enough to make a triangle. And so we are quite happy about that. So I'll go ahead and draw that in right there. So that can be our side, little a, little c. The thing is, this is only case 1. With this case, this SSA case, there is a chance that we can have 2 answers. So far we've seen one where there's no answers, and now we're going to see one where there's 2 answers. So this is case 1. And now I'm going to show you what could have happened with this side that I know to be 12 long. I could have swung it a different way and made the triangle over here. So I'm going to draw a line from here to here. Do you see that little a, which is 12, could also make a different triangle? So little a equals 12. So this is case 1a and case 2a. They're both 12, but they come off of this point here at different angles. Quite different. So let me kind of sketch in here. The first case is this one, the big triangle. I'll try to darken it. The big case is when we swung a equals 12 this way and met the side way over here. And this is angle B, by the way. So this dark big angle triangle, and then the second case I'll do in blue. I'm not sure how much it'll show up, but here's the second case. Here's side B equals 31, and A is going to swing in this way, and then it'll connect to angle A there. So you see the blue one. So we have 2 cases. We have case 1 in pencil, the big triangle, and case 2 in blue, the inner triangle. So just repeating that this gives me 2 sides and an angle, but I have found that I can, with side-side angle, I can come up with 2 different triangles that meet this criteria. So that's called the ambiguous case. So let's go ahead and cut this video and come back in part 2 and show you how to go ahead and solve case 1 and case 2. Be back.